Bring on the next speaker. So, Rustin, how are you, sir?
Good. How are you? Can you hear me?
Yeah, we hear you loud and clear.
Sweet.
So, yeah, Rustin is a university student at Salisbury University?
Salisbury.
Salisbury University. And he leads the Digital Twin initiative and has been doing some incredible work making 3D reconstructions more accessible. Today, he's going to show us how he built an accurate indoor outdoor digital twin without relying on LiDAR or expensive enterprise software. And he'll even be sharing some custom tools that he's built with us today. So, go ahead and get your screen on here. Yep, there you go. And Rustin, the stage is yours.
Alrighty. So hello everyone, my name is Rustin Newbold and I'm very excited to be here today presenting Inside Out, building scalable digital twin workflow with drone and 360 cameras. One thing of note is that this project is an ongoing development. So what even is a digital twin? Well, a digital twin is kind of what it sounds like. It's a virtual counterpart to something that exists in the real world. Typically, these include real-time IoT, Internet of Things sensor data, but for our sake, I'm just going to be simply focusing on the modeling aspect. Digital twins are commonly used for simulation, monitoring, and optimization purposes. Whether you work in admissions at a university and you're trying to sell the campus to a student by providing a virtual model, or maybe you're a professional surveyor who wants a highly accurate model of a building inside and out. And so that raises a question. How can I go about creating these digital twins? And there's three things you need to ask related to that. What type of recreation do you want to make? What type of modeling software are you going to use? And what type of data are you even going to collect? And this project proposes a accessible workflow. And so where can we test this methodology? Well, Norrisville United Methodist Church. The end goal is to actually model Henson Hall, the STEM center at Salisbury University. However, since I'm home for the summer portion, this is something that's local to me. So I'll just be testing our methodology here. And so that you guys understand, basically the church is this nice little dotted outer complex area, and we're going to try to be modeling that whole area as well as the hall that is circled in red inside and out. So once again, Inside Out is trying to present an accessible modeling workflow. So that means we're going to be using consumer grade hardware or free or open source software. So for the outer workflow, we'll be using the DJI Mini 4 Pro, the Emlid Reach RX2, and Waypoint Map. For the interior workflow, we'll be using Argus, my custom 360 camera rig, more on that later, AprilTags, and some kind of distance measuring device. For the software, we'll be using Hera, the first time I'm ever announcing this, but this is also a custom tool that I've been working on, RealityScan for the structure from motion alignment, Liquid Studio for generating the splats, and then SuperSplat for hosting it online. And once again, this is going to be a practical and scalable methodology. If an undergraduate student at Salisbury can do this, I think another student can get in their hands onto this, or maybe even a professional. So onto the tools. So I mentioned that this is going to be free, and I really do mean it. The software is actually going to cost you absolutely nothing, but the hardware is where a lot of your cost lies. And I know that $4,000 number might look a little bit scary, but a lot of that cost actually comes from the RX2 and the drone itself. I know a lot of you guys here are actually surveyors, or at least are going to have access to that type of equipment. So you can actually probably completely disregard the RX2 and possibly the drone as well. You might even have a better drone than the one that I have. One thing of note is that I am assuming that you have access to a gaming computer or some really strong computer, a 3D printer or 2D printer and 2D printer. So what even is Argus? I mentioned Argus is my custom 360 camera rig, but you can literally see it here on the screen. This is the second generation prototype of it. Basically, it's 3 cameras that are sort of stuck together with extendable selfie sticks. I plan to release the files on how to create this later in the future, as well as a step-by-step guide to making it for yourself. Further, what even is Hera? So again, Hera is my custom software that I've been developing behind the scenes. It's kind of like a GUI for FFmpeg and some Python scripting. But basically, it takes all that data that you have from your Argus camera rig, your high, medium, low video files, and it generates these structure from motion ready data sets. Further, there's some cool built-in tools within Hera. One is Capture Plan. Capture Plan is kind of what it sounds like. Basically, depending on what your building layout is, you sort of have these modular components you can throw into the interface, and you can just simply snap them together and generate your indoor layout. And it will use some pathing algorithms to actually determine the most optimal path that you should walk, as well as where you should place the AprilTags, the markers, and what type of distance constraints you should have, as well as a built-in AprilTag generator in the software. So onto the exterior workflow. This is going to look kind of familiar if you've ever done drone surveying, but basically we're going to do a nice top-down high-angle shot of the area of interest. Then we're going to go a little bit lower and fly a double grid oblique flight. I found that works best for me. It's just simply a 45 at around the 40-meter mark, but you can scale that accordingly depending on your work site. Then you're going to get a little bit lower towards the building of interest and fly a 30-meter orbital around. And then just a couple manual flights as well. It just simply depends on, what data you've already collected. Basically, the more data, a little bit the better, because whatever you don't capture, you're not going to be able to model. And again, we're trying to model this entire building. So the more data, the better. Then you'll just do your standard ground control point surveying for like an outer drone workflow, spread your markers thoroughly throughout, survey those. But in addition, you're going to add AprilTags to something called a bridge cluster, which I will talk more about later. But that is going to be our way for tethering the inner and outer models together. You're going to go fly your drone to collect all your data. You're going to perform a structure from motion alignment algorithm within RealityScan. You can see here that, that roughly seemed to align pretty good. So then we'll go about our georeferencing procedures. One thing of note here is that I toggled off the setting called prior pose. And this is because, again, we're using consumer hardware. So the drone is actually just a standard GPS, in the drone. It's not going to be highly accurate. So by turning off prior pose, we're putting more faith in the RTK-surveyed control points because they are more accurate. Then we'll perform our 3D reconstruction by putting it into Lickfield Studio and just tweaking our parameters accordingly. One thing of note is that I only did 30,000 iterations for the splat. Again, this is a testing model. The final one, I'm probably going to bump it to around 50,000. And boom, here's our actual model that is scaled and referenced. You guys at home can sit there and hold your phone up to the screen and scan the QR code. You should be actually able to interact with the model. For whatever reason, it decides to spawn you, the camera below the terrain. Just simply click the orbital icon. It's what looks like on orange on the screen. It'll look orange once you touch it. And you should be able to pinch and zoom and navigate around the model. I'm going to leave this up here for just about 5 more seconds, and then I'll carry on. So once that's all reconstructed, we're going to perform a little bit of a quality assessment. I am hopping back to RealityScan, and I'll explain why later on. But basically, I have 3 individual checkpoints, and by computing an RSME, I found that my worst error in the 3-dimensional axis, or all across 3 axes, was around 4.34 centimeters. Not horrible, but not super great. Honestly, pretty good for a test model, but it can be improved. So for the interior workflow, this is probably the one a lot of you guys are actually waiting for. We're going to perform a capture planning sort of workflow. So a lot of you guys are going to have access to some kind of floor plan. However, I didn't. So I just whipped this up in Photoshop to show you what I'm talking about. Basically, the main walkway into the church is designated by this little blue arrow. And you can see there's a main hall, a main hallway, a secondary hallway, and then a connecting room to that. So my thought is that if you can model this main hall, main room, main hall, and the 2 other components, you can probably model anything in the building and hopefully scale it up further. So by using Hera and putting in our dimensions, you can see actually how many AprilTags we'll need and what type of path we should walk. Pay attention to that blue line. It'll look kind of familiar here in a moment when we actually go to walk through it. By doing it for all, you can see the official capture plan in the top right corner. But for the sake of keeping the graphics the same, the center graphic is just the same sketch, but I just put stars for where all the AprilTags actually are roughly within the building. Then you're going to actually go about the marking process. So basically just, again, putting the ones on the door, the bridge cluster, a couple on the floor, and then across the wall. You want them high and low just so you get different angles, and then measuring 2-way with the distance measure for the wall components. And then on the floor, you can simply use your iPhone's LiDAR or tape measure. It just depends. I found my iPhone's LiDAR just worked just fine. And then you're going to go collect data with Argus. So simply assemble it together, put it around your shoulder, and walk around and collect the data. If you look on the right, there's the GIF of me walking through the main hallway. You'll notice the path that I'm walking looks kind of familiar or actually pretty familiar to the actual path that was generated in Capture Plan, which is kind of cool. And then on the left is me walking through the main hallway. So once all that data is all collected, you'll throw it into Hera or FFmpeg if you choose not to use Hera. And you'll sit there and you'll generate your cubemap ready or structure from motion ready data sets. So what it basically does is you take the 360 sphere and it's in an equirectangular format. If you don't know what an equirectangular format is, look at the bottom left corner. It's sort of that really weird stretched 16:9 ratio frame. But basically it's the 360 sphere wrapped and projected onto this surface. And then that itself gets cut up and generated into these little faces, cubemap faces, which you can see on the right. And that is actually what the software is going to be using for aligning. Hera also generates your cubemap files too, which is kind of nice. So yeah. However, when we go to align, we have a little bit of an issue, and this is where the project is still in development. We can see here that 2 out of our 4 components were aligned. If you don't understand what I'm talking about, if I overlay our prior graphic, you can see the main hall was actually mapped, or the main walkway was actually mapped, as well as the main hallway. However, the secondary hallway and the adjacent room to that was not. And we can also see that by looking at our camera registration. Roughly 1/3 of the cameras were actually aligned. So 2/3 of our data just simply is not being used. And I'm trying to figure out why, and more on that later. But if we keep on chugging and performing our reconstruction, it's a very similar process to the outer workflow. We'll throw that registration into Lichtfield Studio and train it. Again, this is still a testing model, but honestly, for a testing model that is a little bit broken, this is pretty good for what we have so far. Again, it's scaled and it looks very photorealistic. And then once a proper structure from motion and reconstruction is made, we can just simply perform a quality assessment. Again, measure 2 different constraints or more in the real world, and then compare that to what we have in the model. So on to connecting the inner and outer models. I mentioned this term bridge cluster, and this is where I really want to define it. So a bridge cluster is the connecting pathway that has 2 or more AprilTags that is being seen from the inner and outer portions of your workflow. Basically, this is actually how you're going to tether the 2 things together. With the drone, you're going to fly around that area of interest. You want as many angles as possible. And with the camera rig on the inside, you're going to simply walk out the building with it and walk back in with it. You can choose to disassemble it and use a single camera, but if you already have the camera rig assembled, more data, the better. And the whole reason for why we want to connect them is to hopefully create a single scaled and georeferenced model. So the inner model is only locally constrained. In other words, it just has local distance measurements. The outer model has the georeferencing measurements. It has the coordinate system attached to it. So by finding a way to sort of tether these 2 components together, we can almost georeference the interior model as well, and to create a unified, single, scaled and georeferenced model. So far, I would argue that the project is probably around 75 to 80% complete. There's still some improvements with our methodology that we need to work on. One thing of that is our structure from motion alignment. I think there's 3 different ways that we can improve the alignment procedures. One is revising our cubemap generation. Maybe we have too many faces selected, or maybe they're not wide enough. The field of view plays a role, the pitch acts, roll the whole 9 yards like that. And finding a way to find the most optimal cubemap generation procedures is something that I am exploring. The second thing is a segmented indoor reconstruction. And what I mean by that is currently for the indoor portion, you're taking all of your frames and sort of just dumping them like puzzle pieces into RealityScan and then praying that it works. So the way to do the segmented approach is to take the puzzle pieces that correspond to the correct location. In other words, the main room, the first room, the second room, the third room, the fourth room, so on and so forth. And then finding a way to sort of glue those pieces together, these components together, to create a unified single model. And the third thing is finding a way to possibly mask the operator and the Argus camera rig. Again, you are in a lot of the data as well as the camera rig. And structure from motion fails if there's more than 30% alignment or 30% of something that's not moving within the shot. So by finding a way to mask the operator and the rig, aka the data that you don't need, out of the actual data set, hopefully that should also improve alignment as well. The second thing of note for improving the project is georeferencing our Gaussian splat. This might sound a little bit confusing, but the splat that you guys just played around with on the outer portion of the model is actually not georeferenced in the form it currently is in. It's technically scaled properly. However, all of the georeferencing data still lies within RealityScan, which is why I perform my quality check in RealityScan. So finding a way to sort of export that over is of importance. And there are some extensions with that. And the third thing is improving our bridge cluster procedures. So in other words, we need to have more entranceways, more doors open to going into the model. So we don't have this sort of dead reckoning style of navigation. So that there's no hallucination with the coordinate system and stuff. Think of it like more ways to see inside the building so that the scaling is actually proper and referencing is proper. And secondly, I know someone's going to say this, one of the AprilTags was on a door. So anything hinging, if that were to move for whatever reason, that's not good. So by banning placement on any hinging surfaces, hopefully we'll get a better alignment too. And with that, here are some references for the presentation. It was a pleasure being here today. Please contact me if you guys have any questions about the Argus camera rig, Hera, or possibly Iris 2. And thank you for letting me be here.
Yeah, thank you, Rustin. Very, very impressive. Questions from the audience? I'll ask a quick one as someone may type something in. Have you explored any potential ground truthing methods to compare your results and see what your accuracies could be to, a method that is a little bit more trusted, considering you are building a rig and kind of creating your own workflow?
Yeah. So originally, the biggest cost of barrier for at least Salisbury making their digital twin was cost. I wanted to make this as accessible as possible. And so that's kind of why I went the 360 camera route. And the nicest way possible, we had a bunch of 360 cameras lying around. And in my head, I went, well, photogrammetry exists. Is there not a way that we can, use that accordingly? And so hopefully my thought is that, by sitting here and proving to you that, we can actually start to make something that might work, I can possibly get a budget increase or funding to compare it to something like a slam scanner that is actually proper, going through the building and stuff like that, better, or I should say more accurate dimensional constraints in that portion. In other words, getting more awareness to the project to hopefully increase funding and then compare it to something that is, more expensive, but, tried and true.
Yeah, absolutely. Once you start to get with some of those more expensive sensors, I mean, they've been proven to have like the robustness needed. And if you start to get really similar results, that's how you start to prove that this is a viable solution at a fraction of the cost. So
Yeah.
definitely something to consider. Yeah. Um, what part of the project has required the most original problem solving from you?
Probably the alignment and creation of the software. Honestly, the Hera software has kind of came out of absolutely nowhere at me. Originally, when I presented this at the student undergraduate research conference back in April, Hera did not exist, and I had the first generation prototype of the Argus camera rig, and I was getting, for lack of a better word, a really crappy model. It just simply sucked, and it was because I had to manually sit there and code everything. And I'm not a coder. I do not like to code. It's not, in my blood. I hate it. So any way for me to sit there and make that, process as easy as possible, I wanted to explore. And so I actually was taking a Python class at the time, and I learned a lot about coding and making applications, and just, using YouTube University to sit there and learn how to code. With a little bit of help with AI too. I won't lie. But I developed the application. So that's basically, it's as drag and drop as you can get it. And then the incorporation of capture plan as well. I want to emphasize capture plan a lot. I've had to look a lot into, have you ever seen, it's like grocery store path optimization? It sounds really weird, but it's to basically trick you into waiting in a longer queue line. The same exact concepts used in that are actually used in like distance constraints for, like, in other words, you basically pretend like, you are just like, like a 2 by 2 meter cube instead of like a single person in this line. And that's your like visual buffer. That's why there was that buffer for that pathway. It wasn't, directly against the wall or something like that. So exploring a lot of that stuff too. So like basically developing the capture plan software, because originally it was just a bunch of, notes on my paper of, what you should and shouldn't do. I was like finding a way to just make that accessible so it's as easy as possible. Because, again, a lot of you guys, you want something that works. And so finding a way to make something that works and is accessible and it's easy. Again, if I, a student, can do it, you guys, a professional, can probably do it. So, a lot of time spending building Hera, I'll say that.
Oh, fantastic. Well, Rustin, thank you so much for your time. Really appreciate it. And
Of course.
excellent job on the presentation.
Yeah, thank you for having me.
All right.